Are you tired of babysitting multiple Power BI reports? Do your customers spot errors in your Power BI reports often before you or your team do? Are you looking to build more resilient, better tested Power BI reports? Then you've tuned into the right place. Hi, I'm John Kursky, and in today's session, we will talk about how to build more reliable development pipelines with Power BI using the concept of DataOps and tools like Azure DevOps and PowerShell. So a little about me. I have been working with Power BI since 2015, deploying data analytics solutions for small, medium, and large businesses. And much of what I will talk about today is based on my experience with clients deploying Power BI solutions. So I won't bore you with the reading through my resume, but you can see on the screen here my experience and my credentials, as well as how you can contact me after this session. Later on, I will show a demo that includes source code, and the hyperlink to that source code is available in this slide. Let's give you all a roadmap of today's session. First, we'll cover the challenges we face with building data analytics projects using Power BI. We'll cover the concept of DataOps. Third, we'll cover overcoming these challenges using DataOps. Fourth, I'll provide a short demo in which you can take to start your own project later after this presentation. And finally, I'll talk about next steps so you can have incremental success using DataOps. Tell me if you've heard this before while working with a Power BI project. This report looks wrong. This was working yesterday. Why is it broken? This doesn't look right. Why is the dashboard not updated? Why does it take this long to build? If you haven't heard this before, congratulations. You're new to Power BI, or you're new to data analytics projects, or you're a better Power BI developer than I am. Chances are, and from talking with other folks in the industry, you've heard questions like this before. Now, why is that? I've worked in software development for over 10 years, and with low-code tools like Power BI and Power Apps, and I've also worked with high-code tools like JavaScript and C#. And I've noticed that a low-code tool like Power BI empowers folks to build wonderful data visualizations, reports, and dashboards very quickly. But it also introduces a gap in knowledge to the high-code patterns that ultimately lead to long-term success of a project. So let's dive into that gap and how do we address bridging that gap. Enter DataOps. Now, I'm a geek and I listen to tech podcasts on a regular basis. And a couple years ago, I was listening to a podcast that was talking about the concept of DataOps. And I was very interested to see how it was different from the other ops I've heard, like DevSecOps, MLOps, AIOps. And I quickly realized that DataOps is not DevOps for data. While it includes DevOps principles, it also includes Agile and Lean manufacturing principles. A gentleman by the name of Chris Berg and his co-founder wrote a manifesto on DataOps, which includes 18 principles that if you apply those principles to your data analytics projects, you will see increased success and quicker time to deliver to your customers. So today, we're going to cover all 18 of those principles. Nah, I'm just joking. We're just going to cover 3 of those principles today. And those 3 principles I use to very quickly build reliable Power BI development pipelines. So let's dive in and see how those 3 principles helped me out. All right, the first principle is make it reproducible. Reproducible results are required, and therefore we version everything. Data, low-level hardware, and software configurations, and the code and the configuration specific to each tool in the tool chain. I've highlighted what I think is most important to me in this principle, and that's versioning. Versioning in Power BI is a challenge. So let's see if you've had a situation similar to this before. Hey Bob, I think we messed up the Power BI report we published yesterday. The client's got a big meeting in an hour. Can you roll back to last week's version, please? I'll go see if I can find it. This is not how I plan to spend my day. Is this how you find prior versions of Power BI on your laptop? Been there? If so, it's not your fault. Power BI does make it challenging to manage versions. So let's see a little bit in detail as to why. The first challenge is the Power BI format. A Power BI file is a zip file of many files. So unlike other programming languages, like C# and Java, where you can version control to merge changes within a file, Power BI doesn't have that capability. And if you use third-party tools to edit these files, you operate under your own risk. And should you corrupt the PBIX file, Microsoft support will not help you. This is a common pattern with low-code solutions. And while Power BI is not alone, it is vexing nonetheless. The second challenge is the coupling of code, data, and visualizations. The custom code we develop in Power BI is often DAX in the form of calculated columns, calculated tables, and measures, or M-language, aka Power Query, and it is tightly coupled with the underlying data and the visualizations of that data. It is convenient as a low-code solution, but DataOps emphasizes decoupling each component and versioning each. So how do we overcome these challenges using the principle of make it reproducible? Well, I have some best practices. Let's take a look. The first is Git version control. This shouldn't shock you, but if you don't use Git to store your Power BI files, you really need to use it now. Tools like Azure DevOps, which is free for up to 5 users, Bitbucket, and GitHub mean you shouldn't have an excuse to version your Power BI code. If you're unfamiliar with Git, GitHub Desktop makes it super simple to commit and push your Power BI file changes to a repo. It also forces you and your team to provide a description of the changes you make and allows you to recover prior versions should the latest version of your Power BI file have an issue. In short, using this best practice, you avoid the issue that you saw with Alex and Bob. Let's take a look at the next best practice. Separate reports from the model. I've heard many Microsoft MVPs and employees talk about this, but it bears repeating. Following this advice is quite helpful because many reports can look at one version of the data, which eliminates the overhead of fixing the same measure several times. You just make the change once. You can stub out your model by manually entering in data in Power Query to create tables, hard-coding your DAX measures, and then publishing a model to a dev workspace. Your other team members won't have to wait for you to finish working on the model, and they can be productive building the visualizations and delivering products faster. In fact, you can take it a step further and have your team members work different parts of the report in parallel on separate Power BI files and then combine them through Power BI's copy and paste feature. I've used this best practice on multiple projects now, and it's really decreased the time to deliver to customers, which has really increased satisfaction amongst those customers. Let's take a look at the third best practice, which is Institute Workspace Governance. Institute Workspace Governance. Do not intermingle your development Power BI files with the Power BI files that your clients and customers use. You should, at a minimum, have 2 workspaces, one for development, aka dev, and one for production, aka prod. For larger projects, you should have a workspace for clients and customers to test, also test, before moving to production. And finally, the fourth best practice is workspace permissions. For larger teams, limit those who have member or admin permissions to your test and prod environments. Those with member or admin permissions should only publish Power BI files if it is in source control. If you have premium, try deployment pipelines. Hang on, we've got 2 more principles to go, and then I'll show you with a demo how to put these best practices into action. The second principle is quality is paramount. Analytic pipelines should be built with a foundation capable of automated detection of abnormalities and security issues in code, configuration, and data, and should provide continuous feedback to operators for error avoidance. With this principle, I've highlighted the automated detection of abnormalities, which to me means testing. And in Power BI, that can be a challenge. You have DAX for your measures and calculated columns that need to be tested, and you also have your Power Query language that needs to be tested to make sure your tables are well formed. Now, this can be a challenge because Both those pieces of code are encapsulated in that zip file of Power BI. Tell me if this has happened to you before. Hey Bob, is that the Power BI report for sales? Yep, I'm adding a custom column for Carol. She wanted it ASAP. Okay. Can you make sure that the fact table has the data for the East region and the widgets? We had that issue last week, and I don't want to get another call from the East region client. Yeah, sure thing. All right, let's take a look. East region. All right, let's see if the widgets are there. Yeah, there's nothing wrong. Okay. Ooh, I gotta jump on a call soon. Let me go publish this report.
When you forget to get rid of the filter in Power Query.
In that scene, Bob set the filter for the East region and then published the report. Now everyone looking at that data set will see only the East region. That's a problem. This has happened to me before, and I've had other folks on my team make a similar mistake. So how do we overcome this challenge and test for this potential issue before it goes into production? The first best practice is have a test data set. In order to test effectively, you need to have a known underlying data set to validate your Power BI report. For example, if you are importing a SQL database, you can adjust the query to return a constant set of data. Ultimately, the goal is to have a static set of data to work with, so the only variables that would change during a test is the code you or your team has changed in Power BI. The second best practice is test the Power BI tables. As of January 2022, you can't test each line of M code in Power Query that is generated when you build your tables. However, if you follow the prior best practice, you can test to make sure the composition of the tables created by your code are well formed. For example, you could test for the number of rows in a fact table, the number of rows in a dimension, the presence of a value in a column that shouldn't be there, the existence of blank columns, and the values in a custom column are correct. So in the case where Bob set that filter and accidentally kept it there and published it, a test case would have prevented that from moving to production. The third best practice is test the DAX. If you follow the first best practice, you should be able to test that a DAX measure or calculated column has the appropriate result. For example, let's say you have the DAX measure shown on the screen. This DAX measure takes a summation of column Y in table X, and if it's less than 0, produces condition 1, and if false, produces condition 2. To test this DAX measure properly, you should create conditions that test when the summation is greater than 0, equal to 0, less than 0, and if the summation is blank. These types of tests are not just for numeric-based measures and or columns. You can also test for potential issues with time zones, when source columns are blank, etc. And I have a few more best practices to cover for this principle, so let's take a look. The fourth best practice is have a test schema. All tests should result in an output that is consistent so that the team can understand the results and find failed tests quickly. Fortunately, with DAX, we can create that schema. The image that you see here on the screen is an example of a test schema that I've created and have in the demo. And you'll notice it produces 4 different columns. First is the test name, which is a description of the test prefixed by measure, calculated column, or table to indicate what part of the Power BI model is being tested. The second column is expected value, what the test should result in. This should be a hard-coded value or function evaluated to a Boolean. The third column is the actual value, the result of the test under the current data set. And finally, test pass column, which is true if the expected value matches the actual value. Otherwise, the result is false. Now, if you're not familiar with the screenshot that I have here, this comes from a product called DAX Studio. And if you're working on any large Power BI project or doing a lot of DAX work these days, you should download this tool. It's free to use, open source, and a wonderful accelerator for your Power BI project. The fifth best practice is maintain your tests. To paraphrase Edgars Dijkstra, a famous computer scientist, testing will show the presence of flaws, not the absence of flaws. Therefore, as you encounter more issues, and you will, you need to add test cases that address those issues. The goal is to never see the same issue in production twice. The sixth and final best practice is version the tests. Just as I recommended before, you should use version control for Power BI, but you should also use version control on these test cases. That way, your colleagues can run the same tests to check for errors and/or issues. All right, so right about now you might be saying, well, these are great principles and best practices, John, but I don't have time to implement them. Well, you're in luck. The third and final principle is here to help. Orchestrate. The beginning to end orchestration of data, tools, code, environments, and the analytic team's work is a key driver of analytic success. And we have a tool like Azure DevOps that can put this principle into practice. Let's look at the pipeline flow, and then I'll show you a demo. The first step in the pipeline is committing the Power BI file to Git. Once it's in the Azure repo, the build agent will pick it up and move any new or updated Power BI files to a build workspace. The build workspace is used for refreshing and testing, much like a build agent you would use with C# or Java. Once it's in the build workspace, the pipeline will then test the refresh of that Power BI file, as well as run any test on all Power BI files that are in the project. If the builds pass, it will then move the Power BI files to the development workspace, and if it doesn't, it will fail the build and email the team. Let's jump into a demo to see this pipeline in action.
Now, if you go to the link that I provided in the presentation, it will take you to the README file for installing the project for this demo. So let's go over the prerequisites. First, you will need Power BI Premium per user. Power BI Premium per user is $20 per user per month, and that's in US dollars. And I highly recommend having this license assigned to a service account in order for this development pipeline to work. You will also need on your desktop the Azure CLI installed, PowerShell 7. For those who have PowerShell installed by default on Windows, which is going to be 5.1, this now does not work with the Power BI PowerShell, so you'll need PowerShell 7 installed. You also need GitHub Desktop, and also on the desktop, Power BI Desktop. You also need a subscription for Azure DevOps. For those working with Azure DevOps, it's free for up to 5 users, and you're going to at least need project collection administrator rights or organization owner, or have the create new project permissions set to allow in order to install the project on Azure DevOps. With the prerequisites installed, now we need to move on to the installation steps that will actually create the Power BI workspaces and the Azure DevOps project. So the first thing that you'll need to do is copy the PowerShell command, open up PowerShell 7, paste that command, and remember it needs to be in PowerShell 7. This will download the setup-ppu PowerShell script. We'll then run that PowerShell script. And then you'll be prompted for a series of parameters. The first is the name of the build workspace you want to create in Power BI. The next is the development workspace. You'll also be prompted for the account name for the Power BI Premium service account, or the service account that was assigned Power BI Premium per user. As well as the password for the service account. You'll also be prompted for the name of the project you want to create in Azure DevOps. All right, at this point with those parameters entered, there's going to be a 5-step process, at which point during the steps of the installation, you're going to be prompted to sign in to Power BI. And if I go back to the screen here, where the PowerShell command, it's going to start creating the Power BI workspaces. Once the workspaces have been created, it then's going to ask you to sign in again to create the Azure DevOps project along with the pipeline and the repo. Now this may take a couple minutes depending on the speed of your internet. You'll see at some point during step 3, the project that was created in Azure DevOps will appear in your default browser, but that doesn't mean it's finished yet. If you go back to the PowerShell window, you'll see that it's still creating the repo in the Azure DevOps project. This is downloading the source code from GitHub, and then it will create the pipeline, or the starter pipeline, which we'll demo here later on, also in the same project. The fifth and final step is uploading a sample model that we'll use for the demo to the build workspace. And if everything is complete, you'll see a green message at the very bottom that says the Azure DevOps project has been created with the pipeline and the URL to the Azure DevOps instance. After the installation is complete, there is one manual step that you will need to do in order to make sure the pipeline works. So you'll need to go to your Power BI instance and go to the workspace, specifically the build workspace that you created during the installation process. And go to where the data set for the sample model is located. Click the Options menu and click Settings. Expand on Data Source Credentials. Click Edit Credentials. Make sure it's set to Authentication Method Anonymous, Privacy None, and you can skip the connection test. Now, as of January 2022, there is no automated way to set these data source credentials, so you'll have to do this manually for every new data source you include in a project like this. Now that we have the Power BI workspaces created and the Azure DevOps project created, we should now clone the code in the repo to our local machine. So from Azure DevOps, you'll see that project demo is the example I have here. You're going to click on repos, and you're going to see the code up here, and you're going to click on the button on the far right called Clone, and then you're going to hit Generate Git Credentials. The next thing you're going to do is you're going to copy the URL here using this copy button. Make sure that it says HTTPS. Click that. You're going to open up GitHub Desktop. You're going to pick File, Clone Repository, and you're going to pick the URL option and paste the URL into the first text field, and then hit Clone. Now you should be prompted at this point to enter in a username and password. And so I am going to copy the password, go back to GitHub Desktop, type in my username, paste in the password, save and retry. And if everything goes well, it's going to now clone that source code to the local machine. Now that we have the repo successfully cloned to the local machine, we need it to open up in Visual Studio Code so we can look at the contents. So using GitHub Desktop, I'm going to click on the shortcut button, Open in Visual Studio Code. Now with the project loaded in Visual Studio Code, let's take a look at the folders. The first is the image folder, which I use to store images used in the README file. Not so important. What is important is the Power BI folder. If I expand on that, you'll see there is a subfolder called Sample Model. For each Power BI file in the project I want to use in the pipeline, I create a folder with the same name. So you'll see within this folder is the Power BI file, along with the DAX test cases that I've created for the calculated columns, the measures, as well as the table tests. Outside of the PBI folder is the pipeline scripts. Let's expand on that. Now within that, I have a set of PowerShell modules that will help run the pipeline, including the Start CI PowerShell script, which is kicked off by the pipeline. Now, if we look a little deeper into the Start CI PowerShell script, you'll see that we have a series of steps that's going to import the modules into PowerShell, as well as start setting up the options or default environmental variables that were saved into the pipeline when we created that during the installation steps. And then it will go through the process of checking to make sure that those options are available. It will then iterate. Let's take a deeper dive into the Start CI script. Now you'll see in the first couple of lines here, lines 10 through 13, we're importing the modules. And then we're going to set the environmental variables. Now these are looking at the pipeline variables that are defined in Azure DevOps. We'll also check to see if those variables are missing and throw errors if they are. Then what it will do, it's going to look at all the Power BI files that have recently changed using a git command, iterate over those, and figure out where those files are located in the project. Then it will install the PowerShell modules, specifically the Microsoft Power BI PowerShell module if needed. Now again, this is running on a build agent in Azure DevOps. So at the start of a build agent, it may or may not have that PowerShell module installed. So we always need to check for that. Once it's finished installing the PowerShell module, it's now going to iterate through each of the files and try to publish the changed Power BI files or the new Power BI files to the build workspace. It's then going to test the refresh for the new or updated Power BI files. And then, regardless of whether or not there's new or updated files, it's going to identify all the Power BI files, as well as all the tests associated for the Power BI files within the same folder, and run those tests. So starting on line 147 here, it's going to identify the file, get the Power BI report and get information so it can call that report and issue DAX queries to it. So you'll see here on line 163, there is a PowerShell module that I've created called send XMLA, and this is why we need Power BI Premium for a user in order to leverage XMLA and run those queries. Now again, the queries are the test cases that we're trying to run and see if the test cases pass with the recently refreshed or recently created file that's located on the build workspace. Once we get the information back, it comes back in XML format. We'll query those results, see if the test passed, go through each row of the test cases that come back, and then leverage the Azure DevOps shortcut for logging issues by writing to the host inside the build agent if there is indeed an error. And then last but not least, if it did not pass here on this for loop, it will write out another failure and set the expectation in the log. Now, if the failure is greater than 0, it will also write one more log to say how many failures occurred. And if no failures occurred, it will then promote that Power BI file or Power BI files to the development workspace so that other developers can use it knowing that the test cases have passed. Now the Start CI script gets kicked off by the YAML file here, which is referenced in the pipeline. And what you'll notice here is that we are only looking at part 5 of the branch. So when we go to run the pipeline, what we will need to make sure, and we're going to do that right now, is click on the bottom left-hand corner to switch the branch, and we're going to want to change to branch 5. All right, now that we've switched to branch 5, anytime we update it, it's going to kick off the pipeline for this particular branch. You also notice that we're using the Windows 2019 image. This is the one that I recommend using as of January 2022. And then the steps that are going to run is it's going to run that start CI PowerShell script. And on line 23, in order to leverage the encrypted password, we have to reference that environmental variable here. This is a critical step when setting up a YAML pipeline with encrypted variables, so don't forget to have that included in any YAML files you're running pipelines with. Before we try kicking off the pipeline, I want to take a look at one more file, and that's a test case, specifically the calculate column test case. Give you a picture of what's happening when the tests are run. Now, I recommend when you're building those test cases to do it in DAX Studio, but we'll take a look at the contents in Visual Studio. So lines 3 through 9 define some static dates and check cases using DAX for blank dates and static dates. And then, starting on line 11, we're going to build a variable called tests that unions a row, and within each row is the test, the expected value, and the actual value. Note here in the actual value, we are calculating it based on a DAX measure up at the above. So this is looking at the data sets calculation at runtime. And then it will union the next test case. And ultimately, at the end, it will run an evaluation command in which it takes the test, which is a union of 2 test cases, create a variable called pass, so another column, with expected value and actual value. All right, I think we're ready to kick off the pipeline. Now, in order to do that, we need to make an update to the sample model in this project, and then commit that and push that to the Git repo. So let's open up the Power BI file. So a quick way to do that is you're going to right-click, Reveal in File Explorer. I'll put that up on the screen here. Double-click on that, and that's going to open the sample model. Now I've combined the visualizations and the data set in this model. This doesn't necessarily adhere to the best practice I talked about in the presentation, but for the purpose of the demo, I've kept it simple and included the visualizations and the data set together. So we need to make one minor change. So the best way to do that, I have an example here. Let's expand on the fact table, click on the number of characters DAX formula, which should then open up. And we're just going to make a minor change here in which I get rid of the +0. Once that's set, I am then going to save the Power BI file. And with that saved, I can now go back to Visual Studio. And under the source control button on the left here, I can see that the sample model has been updated. So now I'm going to enter a description of the change that I want to commit and push to the Git repo. I'll hit the check mark here. Now this commits it to your local repo. And when that finishes, we're going to click Sync Changes. All right, now that the change has been synced and pushed to the repo, this will automatically kick off the pipeline, and you'll see a running icon here. So if I click on the pipeline and click again, this will show the latest status of the current pipeline running the change that we just committed. So I'll click on the agent job, and you'll notice here that you'll see an output of the PowerShell script that we reviewed, in which it's now going to go out and start refreshing the data set, specifically the sample model data set, and then run through the test cases. Now the test cases I built should pass, and they do. You get a check mark here to indicate that everything has been completed. And the Power BI file should now be moved to the development workspace. Now, if you happen, as you're going through this, get an X check mark while you're setting this up, please check that the service account password that you set up in installation is correct. I've made that mistake in the past. Now, if I hit the back button here, you'll notice that you'll get the agent job saying that that was a success. And if I go out to Power BI, I will also see that under the build workspace, it's refreshed the file recently, as well as if I go to the dev workspace, I now see that newly published file. So now that we've seen when the pipeline succeeds, let's see what happens when the pipeline fails. And more specifically, let's introduce a failure using a test case. So let's go back to Visual Studio and open up the Explore tab. More specifically, let's make a change to the table tests. All right, you'll see here that we have a set of definitions that's going to look at certain filters that are going to apply on the table and start counting the rows in the fact table, the date dimensions, and also check for the blank. So in this case, let's augment the test case that's looking for how many rows should be in the fact table. And we're just going to make a very minor change from the 6 to the 5 and make sure to save that. And as soon as that is saved, you're going to see on the left-hand side, Git should update. And I'm going to enter in a new description. Save that to the local repo. And then I'll sync that back to Azure DevOps. Okay, now that that sync has been committed to the Azure repo, let's go back to Azure DevOps, click on Pipelines, and we should see a new pipeline running. Let's click on that. We're going to see the instance that passed and the one that's running. You'll notice the description that I typed in, set up for failure. We're going to click there. Click on the agent job so we can see the console. And you'll notice that it'll say no Power BI files that have changed. Again, we've changed the test case. We haven't changed any of the Power BI files that are in this project. In this case, one Power BI file. The service account's now logged into Power BI and is going to start running the tests. It's running through the calculate column tests. It's going to run through the DEX measure tests, and now it should run through the table tests, and it immediately fails. If we click back here, you'll see that the failure for the Marvel fact count, which we updated, we changed that 6 to a 5, and you'll notice that it didn't like that. Now, if we go back out, you also see that the errors are logged here in Azure DevOps, as well as you'll get an email, or your team will get an email that that failure's occurred, as well as that file will now not be pushed to the development workspace should that data set have changed or the underlying code have changed. So this is an example of how to create a failure based on a test case update. All right, now that you've seen this pipeline in action, you can use this to start your next Power BI project or help your existing Power BI project. So let's talk about next steps.
I hope you find this starter template helpful, but if you need to ease into this, or you think your team needs to ease into it, I have some next steps to take for incremental success. The first is start with version control. If your folks are not familiar with Git, and they need some time to understand how it works, the best thing is to download GitHub Desktop and have them become familiar with working and committing Git to the Azure DevOps repo. Once your team or yourself are comfortable with version control, the next thing is to start writing manual tests. You can use Deck Studio and use the templates I have in the source code to build those tests. And finally, once you're comfortable with Git and building tests, then it's time to automate. So if you follow these next steps, what does that get you or your team? If you spend less time fixing your reports and data sets and build trust, you have more time to innovate and work on new things. Second, if you're successful, you probably have someone else help you manage the reports and data sets, or even take it over. Using these best practices, you give them the safety mechanism to make mistakes and recover quickly. They'll like you more, and you won't get pulled into support issues. Hey, you listened all the way to the end of this presentation. Thank you. On the screen is my contact information, as well as the hyperlink to the source code. And with that, happy coding, everyone.